Thank you. So I'm Steve Tiki from the University of Chicago. I've been around, I'm going to shift gears away from kind of the media space. We do have a little bit of use of Globus in the media space, but really our focus is the science world. Right? I spent the last 25 years in the science community helping scientists do their science, right? Providing IT tools to do that. And spent a lot of years doing sort of big data for the rarefied science community. Our last speaker talked about the Large Hadron Collider. I like to joke that I get to claim my little bit of the Higgs boson because that entire infrastructure is built on our previous generation of Globus toolkit technology for all the data transfer and security and that sort of stuff. But starting a few years ago, we saw that there was this growing need across the rest of the science world. It wasn't just the big science communities like the physicists and some of the other physical scientists who are really starting to be inundated with data. You see the genomics community hitting it, anywhere in the human clinical research world besides genomics, you have a lot of imaging data, chemistries, biologies, everything, even getting to the humanities. Projects at the University of Chicago of deep mining of textual data that can be petabyte archives of information. And what we were seeing was that the science world was just really struggling with dealing with this data outside of these few rarefied communities. And that's where really what the second generation of Globus, so what I'm really talking about today is the Globus Services was born, to say how do we repurpose and eat our own dog food of that previous generation of infrastructure and bring this to the broader science community, provide something for the other 99% of the science community with tools to help them manage their research data. We did it, the science world, if you're not familiar, in many ways is way behind, right? Because it's a small, fickle market, we often just get the leftovers of the technologies in our space and are repurposing them. And where things like software as a service, cloud-based SaaS, took over the commercial and consumer worlds in the 2000s, it's really just starting to get into the science world. And we're actually a leader in that area, bringing these techniques into science. But a key part of what we do is we are not cloud storage, right? That's not our mission. Rather, we're trying to provide tools that allow customers to plug in their own data system, their own storage system, whatever they are, whether it's local, systems sitting in labs, campus research computing systems, up to national facilities like the DOE supercomputing centers and Exceed facilities, cloud storage, all these things, be able to bring all this into the system, and we provide then a management layer on top of that with research workflows. So what specifically are some of these workflows? Right, so it's a pictorial of the capabilities we have today. First bit, up there in the left corner, we have instruments, right? So this is a broad class of capabilities in the science world, ranging, Matt, I think earlier talked about 6 cows is a terabyte, right? If you're doing genomic sequencing in the ag world. Of course, as you get into clinical research, genomics is taking off, right? I mean, we're working with customers who are doing full sequencing of tens of thousands of patients, many samples per patient, both in different regions of their body as well as over time, right? So you're getting into hundreds of thousands and millions of sequences that people are wanting to do their research, right? And that's getting up to petabytes of data. You have lots of imaging devices, microscopes that are getting very high resolution. Of course, I come out of the DOE labs originally, where we have light sources, X-ray sources and the like that are just crazy amounts of data coming out of that. Right, so the science world is inundated with data. And one of the basic things people have to do is schlep it around, right? I've got data sitting on a facility somewhere, coming out of an instrument that I need to get back to my compute cluster for analysis purpose. How do I do that? Right? How do I make it really easy for users to just get their data, their petabytes of data, move from point A to point B amongst the various systems they have access to? Of course, the next step up is sharing, right? I'll use the analogy of Dropbox. Right? If I want to share a Word file with a colleague, I stick it on Dropbox, click a few things, email shows up in his inbox, clicks on the link, and magic happens. Right? They have access to that file. Works great for Word files, doesn't work so well when you get up to terabyte data sets. Right? So the second capability of Globus is providing that level of simplicity of sharing your very large data as you would get from, say, Dropbox in the small world, right? Just click on a few things, magic happens, and I have data. So if I've got data, say, sitting in my University of Chicago Research Computing Cluster, I could trivially, in about 2 minutes, share that with everybody in this room directly off of that University of Chicago system without you having to go get the accounts on the university systems and all the sort of rigmarole that traditionally researchers had to deal with. Right? So as a user, I can come along and say, share it out with other people, and now my colleagues can download it, take it to their systems, do their secondary analysis and other downstream things. Next step is data publication. Right? So the first two are really about files, right? File transfer, file sharing, and that's where the bulk of the science data is. But I want to go a step further and say I just published a paper. I need to make the data available with this paper. This is increasingly becoming a requirement of the funding agencies, both in the US and internationally, that any research papers written on federal grants, the raw data has to be made available with that so that others can reproduce that science. And so I don't want to just make the files available. I want to associate other things with it. I want to associate metadata with it. I want to have persistent identifiers like digital object identifiers with it. And I want to make, get it out there in a form that others can figure out what it is, download it, get access to it. I want curation on this as well, right? So that I can have, librarians, research librarians and the like in the mix, or my project teams making sure the data that's being put out there, precisely so that others can come along, discover that data, search for my data sets based on the metadata, what's available, download it, get access to it, and either extend my research, reproduce my research, things like that. Right? So in a nutshell, that's what Globus is about today, is providing this cloud-based tool, software as a service tools, to manage these end-to-end workflows around the research data lifecycle. Now, as I said, our community is a little behind in some ways in the use of modern web application user experiences, but that's sort of a big focus for us, right? We see this whole generation now coming up that are really going into their early careers who grew up in the Facebook era, right? That expect web interfaces to actually work, right? Go figure. The command line interfaces and all that stuff, yeah, they're often technical enough to do it, but why, right? And so a big part of our focus is providing these tools in a form that actually is usable. We also, everything we do is a platform as well. So all of our capabilities around the research data management are available through REST APIs so that other research groups can build on our capabilities. So for example, right up the mesa here, NCAR has a system called the Research Data Archive, which is a couple petabytes worth of curated climate and environmental data, with about 30,000 people worldwide who come into their archive, search for things, find data, get derived products, and download that data. And so they've now integrated with Globus as a means to make it very easy for their people to get access to this data. And as I said, our real target market is the nonprofit research market, universities, national laboratories, things like that. We do sell to others, for example, BBFC, the British Board of Film Certification, which is sort of the MPAA in Britain for doing the film ratings, uses Globus as a means for studios to load data to them, right? So we're happy to work with that environment, but our real target is the research market, providing these tools to the end users, but equally providing these facilities to resource providers, to the campus research computing IT folks, to the national facilities, in a really easy to use way, right? Somebody earlier mentioned about how in the police world, it's some of the police people are the IT admins, right? In the research world, it's often the grad students. And so we need tools that are super easy for people to actually administer, not just use. And so that's a big part of the story, and also big part of the value we'll talk about as we partner up with Spectra. And then of course developers, as I said, unlock other app developers who want to build research applications to leverage all these capabilities as well. Now we're a little unusual, as I said, I'm University of Chicago, but we're actually essentially a nonprofit company inside the university. We have this mission of helping the research world, do their science, but in a way that's sustainable. The running joke in the science world is as soon as you get something working, the federal agencies stop funding it. So, we want a business model that will actually allow us to be around for a long time providing these tools. So we have a freemium model where, the basic file transfer is free, but the advanced features for end users, such as the sharing and publication, as well as for administrators, is part of the premium. So we have things like management consoles. So administrators can take their, can see everything happening against their storage systems and manage what's going on, pause, resume, cancel, transfer, sort of manage the workloads against their systems, against their storage. And today, we're kind of the de facto standard within the science world. So all of the national facilities like the XSEED, which is the National Science Foundation, supercomputing centers use us, DOE facilities like NERSC, a lot of the major research universities in their research computing centers are using us. So we're really taking off, and then internationally, a lot of use as well. So, if I come back to this slide and really focus on this picture, it's funny, this morning I actually changed my talk just slightly around with the Arctic Blue product, right? Because what brought us together with Spectra was mutual customers, universities saying, I'm interested in the Black Pearl, and I want Globus. Globus is my research data management tool, so what my users expect as their user interface for dealing with their data end to end. Can you make these things work together? Right? And our answer is, yeah, that's great. That works. That really fits our model very well. It's all about plugging in whatever your storage is, all your storage, and giving your users that advanced interface to it. But so this need for doing tape-based archival storage, right? There's definitely a need for that in the university space, and of course Spectra has a big market in the HPC world. So it's a natural fit. But with the new nearline sort of deep storage, disk-based storage, there's even a more interesting opportunity, I think, which is one of the big struggles we see happening on pretty much every campus at this point is researchers are asking the question, where do I put my data? What do I do with all this data that's happening in my research from my research? I don't have a place to put this. I can go to Best Buy, buy disks, and shove it on my desktops, and that's actually, unfortunately, probably more the norm than the exception. Campuses are looking for solutions that really scale out at a very good price point. They often have high-performance computing storage with their HPC clusters, but that's not really a good basis, right? It's just too expensive for this. And so what we're seeing all these campuses looking for is what we think of as sort of campus research storage, another storage tier, another good, safe place where researchers can put their data for primary storage, where they can share it with their colleagues and know that it's safe, for backup data, archive data, right? And it doesn't need to be a mountable file system, right? They have other systems for that, the HPC clusters and their file systems. So having this sort of storage cloud, this local cloud, with a really nice, attractive price point is very good. Up till this morning, all that was tape, which is not enough for a lot of the campuses. They need, particularly, what you see in a lot of the science data is it comes in, it's active for months, 6 months, year on the tops typically, and then it kind of goes into cold mode, right? That it's they want to save it long term, but it's not as active. So having this combined solution of the disk base for the online access and the tape base for the long term with the long life cycle is a really good fit for these campus research storage solutions. So we're really excited about this combination of Globus with Spectra with the Black Pearl and the systems behind it, right? And so for our market, right, it allows them to continue to get the same consistent user interface that they get from Globus, but with a system that is really, it's turnkey, right? That as an admin in a site, the appliance model of the Black Pearl and the systems behind it combined with the user interfaces of Globus for the end users is a system that's both really easy for the admins to keep running long term, and the user experience that the users need with a great cost point for it all. And then also with Globus providing the administrative interface to all of that so that the administrators can really see what's going on with the users against this system. That's it. Thank you.
Thank you, Stephen.